Hey, this is a video for 7.6, Reduction of Air Pollutants. So go ahead and check out the overview and set up your guided notes. So in order to reduce the amount of air pollutants, the easiest way is to reduce the amount of fossil fuel combustion. And one thing that all of us can do as consumers, as residents of this country, is we can just stop driving cars less, and we can take public transit as often as possible. Now, that is not always possible, but we have a benefit living in New York that we can take public transit and get pretty much anywhere in the city. Now, other methods are pieces of legislation can be implemented by the government in order to reduce the amount of air pollutants. And the government can mandate a maximum amount of air pollutant production. They can mandate the amount of emissions. This has been done through the Clean Air Act. Pollution credits can be given to a corporation, so they can have so many credits that they can quote unquote pollute throughout the year, and once they have reached that, then they would have to pay a fine. There's also the corporate average fuel economy, and basically this is the miles per gallon fuel economy that cars contain. So a car with a higher fuel economy would use less gasoline. Now, obviously, we should be using electric vehicles, but if you do have to use gas-powered vehicles, it is better that they have a high MPG. Now, the Clean Air Act really helped out. It regulated the use of lead, particularly in gasoline fuels. It decreased the amount of lead in the atmosphere. It also established standards for those 6 criteria air pollutants that we've discussed in previous videos. And they also had cap and trade of sulfur dioxide. So what is cap and trade? Well, imagine you have 2 corporations. Both of them are industrial corporations. Both would emit pollutants into the atmosphere. So what the EPA did is they gave each corporation the same amount of pollutants that they're allowed to emit. Now, one corporation might emit this amount and another one might emit much more. Now, the one that did not reach its quota can take those pollutants and kind of sell them to the other company, which would then purchase those extra credits. And this second company would be able to, pollute a little bit extra. Well, what this has done is this has kind of forced some companies to become more energy efficient, become more, to reduce the amount of air pollutants that they are emitting. And this has really helped some companies, but it's also not, it also is a detriment to certain areas because some companies are just too wealthy to care, honestly. So if they're heavy polluters, it's just off of the bottom line. And it's not the perfect system, but it actually has done a lot to reduce air pollution in a relatively short time. Other methods is we could just conserve the amount of energy that we are using. Use less energy from the source. And this is an example of taking public transit instead of driving. Drive less. Maintain your car. A well-maintained car will use less or will have higher fuel efficiency. Carpool when possible. Consume a plant-based diet. When we were discussing agriculture, meat-based diet, cows are horrible for carbon dioxide and methane production. They're really bad for greenhouse gas emissions. And also, all of the feed that is put into feeding those cows, to feeding all the livestock, really does take a toll on pollutants that are emitted into the atmosphere. There's less monocropping, so you're also preventing soil erosion as well. And obviously, you will be lowering the amount of fossil fuels that you are consuming. And with the fewer amount of fertilizers that you are using, you will have less eutrophication, less hypoxia in nearby waterways. Now another method would be to find alternatives to these methods, or energy methods. Like, for example, if you had an energy alternative, you can reduce the amount of carbon dioxide, NOx's, sulfur dioxide, mercury, particulate matter. For example, if you're not burning coal. So we could generate electricity using wind, using hydroelectric, using geothermal or solar energy. Some actual methods that are in place right now one of them is a vapor recovery nozzle. And you'll see this is something that basically prevents a lot of the vapors, which are volatile organic compounds, prevents a lot of the vapors from being emitted into the atmosphere. It is a control device. It's not eliminating the amount of air pollutants. It is minimizing. It's preventing these fumes from escaping while you are filling up your gas tank. There are hydrocarbons that are present in gasoline, and they are volatile organic compounds. Benzene is a known carcinogen. It is found in gasoline. So, vapor recovery nozzle will reduce the VOCs in the atmosphere. If you reduce the VOCs, you're reducing anything that comes from the VOCs, like, for example, tropospheric ozone and photochemical smog. A catalytic converter is used for internal combustion engines. Internal combustion engines release carbon monoxide. They also release hydrocarbons and nitrogen oxides. In this case, nitrogen dioxide. Now, they all have, negative impacts, which we've discussed before. This is what a catalytic converter kind of looks like. Basically, these gases go into the catalytic converter, and it does exactly what it says. It converts them. So the carbon monoxide will be converted to carbon dioxide, which is still a greenhouse gas. It is still an air pollutant, but it is not as damaging as the carbon monoxide. Especially if you breathe it in an enclosed space. The hydrocarbons are converted into water, which is, it's not an air pollutant. And the nitrogen dioxides are converted into atmospheric nitrogens. Now, this doesn't work perfectly. It is pretty efficient, but it doesn't get rid of everything. So you are still releasing carbon monoxide. You are still releasing hydrocarbons. You are still releasing nitrogen dioxides. However, the amount is greatly reduced. So we are reducing the emission of these three compounds. Another example or method is to have a scrubber, and a scrubber is in use in a coal-fired power plant because the ash and the soot is very toxic that is released when you do burn coal. So what happens is you have the gas that has all the particulate matter. The gas is then sent through the scrubber, which has water that drips down and collects a lot of the particulate matter, the mercury, some of the sulfur that is coming out of the coal, the exhaust. And you collect that, and the clean gas or the clean exhaust, cleaner, is emitted into the atmosphere. This, again, is not 100%, but it does a great job of reducing the sulfur. An electrostatic precipitator is great for removing particulate matter. What happens is you have these charged areas, you have these positively charged plates, you have these negatively charged rods, you have an air current that is flowing across there. And with the air current, you have this particulate matter. Particulate matter hits these rods that are charged. They get an electrical charge. The particles coalesce, and that means that they clump together. And when they clump together, they will be reducing the particulate matter because it's going to be attracted to the positive. And then the cleaner air that has less particulate matter will pass through, and you can simply wipe off these plates and discard the particulate matter. You're not eliminating the particulate matter, but you are reducing the emission of it. You still have to discard this. So oftentimes this will go into a landfill. But you are reducing the amount of particulate matter that goes into the atmosphere. Now another method is fluidized bed combustion, and this is a mock-up of a system. Basically what you have is, this is also for a coal-fired power plant. And when you're having a coal-fired power plant, you're basically heating up water to generate steam, and that's what this blue represents. So you have coal that is granulated, like crushed coal, and that comes in here into a bed of calcium carbonate. It doesn't have to be calcium carbonate, but oftentimes it is calcium carbonate. And then you also have pressurized air that comes up to aerate the coal and the calcium carbonate. And this will help to absorb the sulfur dioxide and will prevent sulfur dioxide from being released into the atmosphere. And this sulfur dioxide, when it reacts with the calcium carbonate, will produce calcium sulfate, which is then collected. And the calcium sulfate can be used to make gypsum. And then you have the clean air, or the cleaner air, emitted through the top. Now, this will reduce sulfur, like I've described, but it will also reduce the amount of NOx's that are released into the atmosphere. Another one is a baghouse filter, and this is kind of how it sounds. Basically, you have this contraption where you have these filter bags, kind of like a filter that you'd have on your vacuum cleaner. You have the particulate matter, you have the air, the polluted air, that, particulate soot-filled air blowing in, and then it kind of fills up this area, and then the air is trying to go up. The particulate matter will not go up. It will be attracted to these filter bags, and the gas that is emitted is cleaner, and the particulate matter can collect at the bottom, and then that can be sent to a landfill. So a baghouse filter will reduce the amount of particulate matter. Now I just gave you a bunch of information how to reduce air pollutants. I would like you to respond to this check for understanding. And now, to practice your FRQ, I would like you to describe a method to reduce tropospheric ozone formation in urban areas. I hope that this video was informative. I thank you for your attention, and I will see you soon.